Hello everyone, myself A.Yadagiri, Assistant Professor, Department of EEE, MLR Institute of Technology, Hyderabad. I am also the faculty of the Basic Electrical Engineering. In the last session, we have discussed about the what do you remember resonance condition in the RLC series circuits, how we are able to get the resonance condition, and after that, how we are able to get the current flows through the circuit under resonance condition, and how much impedance offered by the network, and also based on that, how much amount of the power absorption taken place. So these many things we have discussed in the last class. In this session, we are going to discuss about the under the resonance condition of the RLC series circuits. So we are able to get the resonance frequency value. So that is FR or F naught. And after that, we need to discuss about the what does it mean by bandwidth of the network? And after that, we need to discuss about the quality factor of the circuits. So these many things we need to discuss in this session. So now let's begin the session. So first foremost thing is a resonance frequency. So the resonance frequency is going to occur in the resonance condition of the RLC series circuit only. So based on that, the frequency at which the resonance condition, so is called as resonance frequency. The frequency under the resonance condition is simply said to be resonance frequency. So that is denoted by the either FR or also we can say F naught. So under the resonance condition, so the net reactance should be equal to 0. That means XL minus XC equal to 0. Then XL equal to XC we can say. So we know that XL is the inductive reactance of the coil, that is a 2 pi FL. Under resonance means FL become FR. Then under this condition, XC is the 1 by 2 pi FC. Then F means is FR only. So this will be now equation number 1 we can consider. So you need to substitute, we need to substitute these values in the above formula. Then we will get the 2 pi FR into L equal to 1 by, it is a 2 pi FR into C. So FR we need to send the left side, we will get it as FR square equal to 1 by, it is a 2 pi whole square because we got the 2 times of 2 pi. So then into root L, simply LC. And both the cross multiplication, based on the cross multiplication we will get this one. So FR equal to, it is a square root of 1 by, it is a 2 pi whole square into LC. So then after simplification, FR equal to, then it is a 1 by 2 pi. So keep write separately. Then this one is under root LC. So therefore, the frequency at which the resonance condition, that is a FR, or also we can say F naught equal to, it is a 1 by 2 pi. It is a 1 by 2 pi root LC. It is a 1 by 2 pi into the root LC. This is a resonance frequency, that is FR equal to 1 by 2 pi root LC. So based on this we need also solve the simple numericals. That's why we need to remember this formula, that is FR equal to F naught, FR or F naught both are same means. So we can say resonance frequency, the resonance frequency should be equal to 1 by 2 pi root LC. So this is resonance frequency. The frequency at which the resonance condition is set to be resonance frequency, that should be FR or F naught equal to 1 by 2 pi root LC. The next one, we need to find the bandwidth of the network. So the bandwidth is nothing but, so it is the range of the frequency over which the circuit current should be equal or maximum of, equal or greater than. So it is the range of frequency. It is a range of frequency over which the circuit current is equal or greater than the 70.7% of its maximum value. Its maximum value of the curve is said to be simply bandwidth of the network. I mean to say the bandwidth of the frequency or bandwidth of the RLC series circuit is defined as, so it is a range of the frequency over which the circuit current is equal or equal or greater than the 70.7% of its maximum value. So under this curve is said to be simply bandwidth. So this is the bandwidth of the network. So this value should be the 70.7% of the maximum value. 70.7% of the it is IM. So also sometimes we can say it's a peak value upon root 2 I mean to say it's a RMS value of the current. So that corresponding width of the frequency simply say bandwidth of the signal. So the bandwidth can be denoted by the capital BW here. BW equal to, it is the F2 minus F1, where F1 is the lower cutoff frequency. This one is a lower cutoff frequency. It is a lower cutoff frequency in measured in terms of the hertz, and also the F2 means it is a upper cutoff frequency. It is a upper cutoff frequency. So again mentioned in terms of the hertz only. So therefore we need to say the bandwidth should be equal to the F1 minus F2. So this is the bandwidth of the frequency curve under the resonance condition. So what does it mean bandwidth of resonance condition means? So it is the range of the frequency over which the circuit current is equal or 70.7% of its maximum value of the frequency curve is said to be simply bandwidth of the signal. So then bandwidth equal to the, we can say, lower and upper cutoff frequency difference we can consider as the, so bandwidth. This is the bandwidth. So based on this one, we need to find the F1 value. F1 equal to, it is FR minus, so 4 times of the FR means, sorry, it's the R times of the, it is a R times of the 4 pi L. Then F2 equal to the, again, FR plus R times of the 4 pi L. So this is the way to find out the bandwidth of the frequency, that is F1, F2. So this is the bandwidth. Then BW equal to F1 minus F2. F1 is we are able to get based on this formula, and F2 value we are able to get based on this formula, that is FR plus resonance frequency value plus R upon 4 pi L. So based on this one we will get the bandwidth of the frequency under the resonance condition. So this is the end of the bandwidth. Then next one we need to find out the under resonance condition quality factor. This is also called as the voltage magnification factor. Also say it is a voltage magnification factor. To say then how much amount of the voltage appear across. How much amount of the voltage across the inductor and also the voltage across the capacitor should dominate, should present the greater than applied voltage. So that's called simply the voltage magnification. Whatever the voltage value appear across the inductor or capacitor is dominate on the applied voltage, which mean to say it's a ratio of the voltage across the inductor or capacitor is greater than the applied voltage. That's called voltage magnification factor. So based on that one we can also said to be the quality factor of the system or quality factor of the network. So based on that one we can say the quality factor should be equal to, that is a QF equal to, it is a VC over R VL upon the applied voltage. So this means we can say either VL or VC, then upon V only, then we will say it is a I into XL. So divide by the here I into Z. So both I's are going to get cancelled. Finally quality factor QF equal to then XL upon Z means R only. XL means it is a omega L upon R only. Then omega means it's a 2 pi FL upon R only, then it is R only. So then quality factor Q equal to 2 pi. FR value we need to substitute as, it's a 1 by 2 pi, so root LC. So 1 by 2 pi root LC divide by R into we can say L. So based on the simplification we will get this one as a quality factor should be equal to, it is a 2 pi, the 2 pi that is a 2 pi whole square we got. Finally 2 pi whole square we got, not 2 pi whole square. Based on these two we will get cancelled together, these two are, and based on this one 1 by R under root of L square upon LC we got. This is the root LC, means we will get this simplification after, then we will get this. So based on that the quality factor should be equal to, so it is a 1 by R root over LC. This is the quality factor offered by the network under the resonance condition. Either we need to say the quality factor should be this one. Finally the quality factor of the system, that is a QF equal to either 2 pi FR into L upon R, or otherwise we can say 1 by R root over LC. Also we can say the quality factor of the network. So this is the quality factor. Also we can say the voltage magnification factor of the whole networks. So this is the quality factor under the resistance condition of the RLC series circuit. The summary of the session, till now we have discussed about the what does it mean by resonance frequency. So resonant frequency, we are able to represent either FR or F0, which means the frequency at which the resonance condition is set to be resonant frequency. So that value should be 1 by 2 pi root LC. So this one we have derived in the session. Then after that we need to, we have determined the bandwidth of the signal or the bandwidth of the frequency. So the bandwidth means we are able to draw the graph between that is the current with respect to the frequency. So which is defined as it is a range of the frequency over which the circuit current should be equal or greater than the 70.7% of its maximum value of the frequency curve is said to be the bandwidth. So this is the bandwidth of the signal. So it's a peak or maximum value at this instant. The corresponding frequency is said to be resonance frequency. Then based on the 70% of its value, we will get the bandwidth. So this is the lower cutoff frequency as F1. So this is upper cutoff frequency as F2. So based on this one, BW equal to it is F1 minus F2. So this is the bandwidth. So the bandwidth also we have clearly determined from the network of from the frequency curve or the network. So based on the frequency. So then after that also we have derived the quality factor. So the quality factor, other name is the voltage magnification factor. So the voltage magnification factor is nothing but it is a ratio of the voltage across the inductor capacitor is greater than the applied voltage is said to be voltage magnification factor or the quality factor. So that value should be equal to the quality factor equal to so it is a 2 pi FR into L upon the R. Otherwise also we can say 1 by R root over LC. So this is the quality factor of the network under the resonance condition. So in this session till now we have discussed about the FR value, then bandwidth value and also the quality factor under the resonance condition. So this is the end of the session. Thank you one all for this whole session. In the next session we are going to discuss about the problem based on the resonance condition. To say what does it mean by quality factor and what does it mean by how you are able to get the quality factor value and also the FR value and also the bandwidth value and also the maximum current value in the resonance condition. So thank you and all. This is the end of the session. Thanks for watching.